Hi guys, welcome to our first video on quadratic equations. These problems come up quite a lot in the exam and they're not done too great, to be honest, so that's why I thought I'd do a video on it, help us with some of them. Basically there's three things you need to know for quadratic graphs. Number one, what the roots are. The roots are where it cuts the x-axis, so for instance where B and C is on this one. Where the y-intercept is, that's where it cuts the y-axis, where A is in this one for instance. And where the middle of the roots, which is called the turning point, which is here, turning point, where it turns. They're the three things you need to know. If you know how to find these three things in any version of any graph, you know how to do all quadratic problems. But sometimes it's written in different ways, it can be difficult to break down, but there's some key steps you have to think about, and they're the three things you need to kind of know. So that in this problem, for instance, another thing to know actually before we start this problem is this. A lot of people don't realise this has got anything to do with x and y coordinates. Y equals, the y coordinates equal 4 times the x coordinate squared plus 4 lots of the x coordinate minus 3. That's what that means. These are x and y, not in a coincidence, they're related to the x and y axis and they're related together, and it gives this shape if we plotted all the points. So for this particular one, it says find the coordinates of A. Well, coordinates of A, if you ever look there on the graph, x will be 0 at that point. It's on the y-axis, so x is 0. So I can put that into that equation. X is 0, 4 lots of 0 squared, plus 4 lots of 0, take away 3, so A is negative 3. Looks about right too, it's 3 under the graph, makes sense. A is negative 3. Second one, a bit more difficult, says find the coordinates of B and C. Well, B and C are here on the x-axis, that means the y value is 0. So I can set y equal to 0 in my graph. So I've done that here. Set y equal to 0. Now I've got that equation there. To solve for x, I can't just rearrange it, so I have to factorise. Again, that's something that you should be familiar with now, but if not, look back in previous videos. So if you factorise that and solve it, end up with a half and negative 3 halves. Now b is negative 3 halves. How did I know that? Look at the graph again. B is the negative 1 and C is the positive 1, so that must be in that order. That must be in that order. Okay. Last one, calculate the minimum value. This is something people don't really get either, okay. It's the middle of these two roots. A symmetrical parabola, symmetry. So the middle of the two roots, we have to look what the two roots are. We've got negative 3 halves, and we've got a half. Now between negative 3 halves, negative 1.5 and a half, there's two difference. If there's two difference from there to there, that means half the way would be one difference. So negative 3 halves, negative 1.5, add 1 is negative a half. So that's the axis of symmetry, negative a half. Now how am I going to get the y value? Put it back into that equation. That's what I do, I put it back into that equation there. So 4 times negative a half, 4 times a half, negative 3. If you do it on a calculator, you end up with y is negative 4. Then you've got turning point, negative a half, negative 4. Looks about right too, doesn't it? Look, that's kind of what it looks. It's lower than that one, it's lower than A, so that makes sense, and that's our value for that. Okay, thank you. Okay, so let's have a look at this other problem then. Okay, now the diagram below shows part of the quadratic function with the equation of the form y equals k x minus a x minus b. The graph cuts at 0, negative 6, and the x-axis at negative 1, 0, 3, 0. Write down the values of A and B. So this one, it's a wee bit of a different flavour of problem compared to the one we had before. Last one, what they did is they didn't give us any information about the roots or the intercepts, and we had to work all of them out ourselves using the equation. This time they'll give us lots of information, we'll have to work the other way and get the equation. Now, this form of the equation here, this is the roots form. How do I know it's the root form? Well, there's two parts to it. Remember, quadratics have got two roots. Okay, now see if it said a square anywhere, that's more to do with the turning point. Basically you can express quadratics as a representation of the roots times a constant, that's what that k is, or as a turning point plus a shift, move either way. So this is the kind of roots version. So it says what are the values of A and B? Well, A and B, basically if these are the roots, will just be the two roots, so it should be x minus 1, which is going to be x plus 1, x minus 3. So what does that look like again? So that's what the equation would look like if you put the roots in. Because remember, you always minus the roots. If I solve this equation here, set equal to 0, that would come out to be negative 1. To solve that equation there, that comes out to be 3, which would be the root. So then we just compare that to our thing up there. Well, it says negative a. Well, that means a would have to be negative 1, because the only way you can get plus 1 is if you negative 1. Okay, to get 3, you'd have to take away 3, so that's why it's b. So it's basically just saying read off the roots, and that's what you've done there. They're the two roots. Calculate the value of k. Now this one's a wee bit more unusual here, right? We've got this function here, y equals kx, x plus 1, x minus 3. This has got that equation already, and that's not going to change in terms of the roots. The roots are always the same. Now we've seen them. The k bit, well, how can we work that out? We need to use another point. We can't use the two roots, because if we use the two roots, we're just going to end up with 0. That's what roots mean, the y will be 0. So we have to have at least one other point if we work it out, but there's given us another point, it's given us the intercept. So that's saying at one point on the graph, the x value will be 0, and the y value will be negative 6. Now I can use that information with my previous information to find the roots, so that's what I've done here. So at that point, x was 0 and y is negative 6 at that point there. So I fired that into my previous equation. Instead of writing y, I wrote negative 6. Instead of writing x, I wrote 0 every time I look at that equation. Now if you do that, you'll end up with negative 6 equals k times 1 times negative 3. Do that, you get negative 3k equals negative 6. If you solve it, you'll end up with k is 2. So the equation for that whole thing now, the equation of that quadratic is 2 x plus 1, x minus 3. Okay, so again, quite a common one, that one. Comes up a lot again. Okay, so look out for ones like that. Turning point, again, it's asking for this symmetry stuff. We've got negative 1 here as one of the roots. We've got 3. Remember, it's symmetrical. So that means there's 4 between here and here. So halfway will be 2. So halfway will be 2. Negative 1 plus 2 is going to be 1. So the x value is 1. And that's what I wrote here. The axis of symmetry, x is 1. How do I find the y coordinate? Same thing I always do. I sub it back into the equation. Now remember, I knew that k was 2, so that's where that 2 comes from here. That 1 and that 3, negative 3, come from my equation up here. That one up here, and that one. I just put in the 1 for the x, because that's where my x coordinates are, here and here. And then I just solve that, so it would be 2, 2, negative 2, so it's negative 8, so turning point is 1, negative 8. Whenever we do these problems too, we should check for common sense. 1, negative 8, does that make sense? 1, yep, it looks positive, the root, so 1 makes sense, and it's less than 3, so that's ideal. Negative 8, does that make sense? Well, that's negative 6, it has to be lower than that. Yep, negative 8 makes sense, so that passes my common sense test, so I'm happy with that. Okay, let's hope you understood that. Hi guys, so I thought I would show you one of these problem solving ones that can come up in quadratics as well. And this is a particularly difficult one, and I picked this one because it's a wee bit cryptic as well as being a quadratic one that people find difficult. So we've got a lawn here. It says the breadth of the lawn is x metres, the length of the lawn is 3 times its breadth, the area of the lawn equals the path, show that 3x squared minus 5x minus 2 equals 0, and hence find the length of the lawn. And it tells you the sides are 1 metre round all the sides. Now, what I think is quite difficult with this one is, I think it's a very badly written question for a start. It says there, show that 3x squared minus 5x minus 2 equals 0. Well, show what equals that would be my initial question, but these kind of questions do sometimes come up. And the key to decrypting it, to breaking down what that means, it tells you here the length of the lawn is 3 times its breadth, the area of the lawn equals the area of the path. So what you do is, it's really when you find the length of the area of the lawn, really, and I want you to find the area of the path. Once you find the area of the lawn and the area of the path, okay, and then really set them equal to each other. That's what it's asking you to do. So, find the area of the lawn is actually relatively straightforward, isn't it? And I've kind of done that here. The lawn would be x that way. It says it's 3 times that on the other side, so it's 3x that way. So that's relatively straightforward. X times 3x squared, and that's our answer for that lawn bit. Now the path's a wee bit harder. I've put it into kind of 3 sections here. We've got that bit 1 times x, so I've called that x in there. That bit there, 1 times x, so that's where I got that second number 1x from. This bit here, well, that'd be 3x times 1, so that'd be that bit from here to here, and then the bits there are 1 times 1, so that's 1, and that's 1, so you end up with 5x plus 2. Now say 2 are equal to each other, so you end up with that, 3x squared. So if you rearrange that equation, you get what they were after. Now that was a rather difficult one, I've got to be honest, okay. But the key with this one, why I did this one, is that these kind of difficult ones come up all the time. But the key is, it's told you to answer the first bit, so everybody should have a go at the second bit. Hence find the length of the line. There's only a couple of ways I've told you how to find for a missing variable. So put the letters on one side, put the numbers on the other side, or factorise. This one here can be factorised. How do I know it can be factorised? See if you took the discovery of this, it's a perfect square, so I know it can be factorised. So I'm going to factorise that, and that's what I did here. End up with my 2 brackets, factorised, look at that. End up with 2 answer, 1/3 and 2. Now, it said the length of the line. What's the length of the line? Can it be negative 1/3? It's a length. That'd be mental. So it's not negative 1/3. The answer is x is 2. The length is x is 2. So the key thing I want to highlight there is when we're doing these type of problems, even though that first bit was rather difficult and a bit cryptic, we should be having a go at the second bit, which is worth 4 marks, worth more marks. So make sure you're having a go at these second bits. But have a go at the first bits as well, if you can kind of understand what I did there. Okay, thanks for listening. So after the next one, this one's a relatively straightforward one, comes up again quite a lot. It's told us the function passes through the origin, so the quadratic can be simplified to y equals ax squared. It's told us that. It says find a. What it's really testing here is, do you know that when it gives you a coordinate, like 550 for instance, do you know what that means? Do you know that relates to the equation? Do you know that means the y bit's 50 and the a bit and the x bit's 5? So all we do, if we ever see something like that, we sub it back in. X is 5, because that was the point. Y is 50. Oh dear, I don't like to rub it in, I'll rub that out. It's a bit like this. So x is 5, y is 50. So I just sub that in, work it through, 50 into that bit of the equation, the y bit. 5 in that bit of the equation. 5 squared is 25. Flip it round, 25a equals 50. Divide both by 25, you end up with 2. That's your final answer. Relatively straightforward, but again, one that's not done amazingly well. Okay, let me know if you get any questions. Right, so this one's a different one. We've got an arch over a bridge. We're going to find, given this version of the equation for the quadratic, that's a square, so that means it's completing the square version. Remember, that tells us about the turning points, how it's been shifted and moved over. Now, what might be hard about that first one, the quadrant, the turning point, is that is written not like we usually write it. The way we usually write it is we write the square bit first and the number. So I've wrote that here, minus x plus 3 squared plus 20. People struggle reading this off. Basically that means it's been shifted over 3 and moved up 20. But again, we've got to apply a wee bit of common sense too. 3 and 20 are the two numbers, right? Now, it couldn't really be negative 3 because that'd be over here somewhere, wouldn't it? That'd be there somewhere, you know, where that dot is. 3's that way, 20's that way. A graph really helps this one, but basically this bit should be settled to 0 and solved. 3 and then the 20 just come from this bit. So this one's been moved over 3 and up 20, and that's where the turning point is 320. Now the axis symmetry, well that's kind of already done in a sense. To find axis symmetry, all you do is you set the square bit of the equation, x minus 3 equal to 0, and then you solve it, x is 3. Big mistake people is they just write 3 as the answer. 3's not the answer. X equals 3 is the answer. That's why it's an equation. It's got to have an equal sign in it if it's an equation. The next bit says find A and B have the same coordinates. A is 0, 11, so take the coordinates of B. This again, hopefully you're starting to see this here, is that this symmetry thing gets tested all the time. That's 0, 11. So we know the coordinates of B already are 11 something. That bit there, well, we know that's 3 in the middle, because that's where that was, the axis symmetry bit. So if that bit's 3 and that bit's 11, that means that bit must be 6 because of the symmetry. 3 plus 3 is 6, so the coordinate of that one will be 6, 11. Okay, so that's kind of how we do the kind of ones, but this was more of a completing the square one. Okay, so another completing the square one here. This one's written more in the kind of standard form, with the square bit first and the number there. So that means again it's related to turning points. Remember, there's two ways to write these. You can write them root, which is, you know, we'll have x minus 2, x minus something, they're the roots, or you can have the completeness square form that relates to the turning point. So that's what really what's happened, it's been shifted over 2 and moved down 9. Because that's what the minus 2 and the minus 9 mean from the 0, 0, the origin equation. So we can kind of see what by reading off again there, but again, looking at common sense, there's the numbers are 2 and 9. Well, 2, that makes sense, 2's there. Could be plus 9, that'd be up there. So negative 9's down here, that makes sense. So the turning point is 2, negative 9. Nice and straightforward, okay. Coordinates to see. Now, again, this is about is how can you apply your algebraic knowledge of this graph back to the algebra of the equation. So we have to think here, we've got this equation that tells us how the x and y coordinates are related. Yeah, that's the equation that tells us how the x coordinates. Do we know any of them? Well, I already know the x coordinate for that one is 0. Must be, because it's on the y-axis. Put 0 into that equation, boom. 0 minus 2 squared, minus 9, boom, 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 get minus 5. So the coordinate for that one is 0 along, negative 5 down. Does it make sense? It's under the axis, it's higher up than negative 9. So yeah, that all makes sense, passes the common sense test. Find the coordinates of B, of testing our symmetry again. That one was negative 1. In the middle, we worked out the turning point was 2. So if that's negative 1 and that's 2, that means there must be 3 different between the two. 3 there, so that means there must be 6 different all the way. So that means 6, negative 1 plus 6 is 5, so that must be 5, 0. So that's how we've got that one again, using that symmetrical fact, okay. So 5, 0. Again, hopefully we're kind of starting to pick this up now. Right, so we'll have a look at this one. It says, first step, factorise that thing. So what's funny looking about that is usually we put the x squared first. This time we put it there. So I'm going to rewrite it now. First thing I do is just rewrite it the exact way I usually would have it, with the minus x squared plus 6x plus 7. So I've done that. Factorise it again, just use your cross or your table or whatever way you want to do it to get the factorised roots there, and that's the 2 factorised roots, so that should get your 2 marks. Second bit says find the roots of the equation. Now the roots of the equation, remember, were y equals 0, so we just set that stuff here, equal to 0, which is already done. Solve it. Do that, set them both, 7 and negative 1. Does it pass my common sense test? Let's double check. Now that one's there, negative 1, aye, that looks like it could be negative 1. 7, yep, that could be 7. It's much more positive than it is negative, so that makes sense. So I'm quite happy with that, Now the coordinates here of the turning point, which is the last bit, well again this is the same thing, we should be coming back to back here. There's the 2 roots. It's symmetrical. Between the 2, that's negative 1, that's 7, there's 8 difference. That means in the middle, between that root and there, to be symmetrical, there must be 4 different there, so between there and there, so that's 4. Negative 1 plus 4 is 3, so that's axis symmetry, x is 3. How do I find the y coordinate? I'll have to go back to the thing that tells me how the y and x coordinates are related. There it is there, 7 plus 6 times x coordinate minus x coordinate squared, fire that in. 7 plus 6 3's minus 3 squared. Work it out, gives me 7 plus 18 minus 9. Work it out, gives me 16. Now my root then is I've got x is 3, y is 16, so the turning point is 3, 16. Does it pass my common sense test? Yep, 3 makes sense. 16, quite positive, quite happy. So, now we've finished these set of slides, hope you've got a better idea of the quadratic stuff. If you really want to know if you've learned how to do it, what you should do now is go back through the video, watch the problems, have a go at them before my explanations. If you can do them all before my explanations, then you've probably got fluent with it for a moment. If you want to really master it, you should really go back maybe the next day or 3 or 4 days later and try and do them all again once it's out your short-term memory. And if you can do them all again, then you've mastered it. But hopefully you've picked up some of the key points here about symmetry, about the different forms, you know, is it the root form, is it the complete and the square form, and also some of the problem solving aspects of it. Okay, thanks for your time, any comments would be great. Cheers.